Okay, going to look at a couple examples here of exponential functions and how we can use them. In particular, probably the most popular example of exponential functions, computing the value of an investment, which earns interest. Okay, so there are two formulas in the notes. We're going to do an example, very similar examples using each formula. So I'll talk a little bit about interest here in a minute. But so the problem is this: find the value of an investment of $20,000 invested for 5 years at an annual rate of 12%, okay, when interest is, okay, first compounded quarterly, and then we'll do a second example where interest is compounded continuously. Okay, so let's look at this. So for the part A, okay, compounded quarterly, what does that mean? Okay, well, when, very, long time ago, when the whole idea of interest was developed, pretty quickly after it had been around, somebody decided, well, if I'm going to charge you 12% per year, for holding my money, then what if I only want to let you hold my money for a partial year? Okay, so compounding interest, which just means adding up the interest, doesn't always happen once at the end of each year. Sometimes we take that interest rate and break it into little pieces and charge a portion of that rate during one of several periods. So if you tell me you're compounding interest quarterly, that means 4 times a year. So in this investment, you will earn interest 12% total per year, but it's going to be paid out in 4 separate periods, okay, about 3 months apart. So every 3 months you'll get a fourth of this interest. You'll get 3%, okay, of return on your money. Now, of course, this is a hard thing to do, to go from the very first day of the investment to the last day of investment, adding up interest a little bit, every quarter. So we've got a quick formula for this. If I want to compute the value of this investment, I use, I think, the first formula in the notes. Whoops. Okay, it tells me the final value of the investment, A, is P times 1 plus R over N to the power NT. Okay, now for our investment, P is the principal. It's $20,000. It's the amount we're investing. R is the interest rate, which is 12%, which as a decimal is 0.12. Okay, remember, 12% just means 12 over 100, which is 0.12. Okay. T, the amount of time, is 5 years, so T is 5. And since we're compounding quarterly, and they tell us in the problem we're compounding some number of times per year, we need this thing called N. Okay, quarterly means 4 times a year, so N is 4. Okay, so for our investment, the value A after 5 years will be 20,000, okay, times 1 plus R over N, okay, to the power N times T, so 4 times 5. Okay, so I can type that into the calculator, and when I do, I get this number. I get, of course this is a dollar figure, about $36,122.22, let's say. We usually round dollar figures to the nearest penny. Okay, so 12% interest, compounding it 4 times a year for 5 years. This is what our money would turn into. Okay, about $36,000. By the way, if anyone can find a 12% per year investment, you might let me know. That's a pretty good rate right now. Okay, but one other scenario, and by the way, if I had asked you to compute this investment compounding instead of quarterly, monthly, it'd be the exact same thing, except N would be 12, because there are 12 months in a year. Okay, but there is a different formula, and it's this one. It's for compounding continuously. So the value of an investment is P times e to the power RT. Okay, there's no N in this formula, because when you compound continuously, you're basically compounding infinitely often. Okay, so everything's the same up here, except we don't have an N. And in this case, we're going to get 20,000, okay, that's our principal, times e to the power R times T, so 0.12 times 5. Okay, and you have to be kind of careful when you type this in to make sure you raise e to the whole power here, 0.12 times 5. In fact, just to kind of let you see what I would type in on something like this, on the calculator you type 20,000 times parenthesis, well, actually we don't need that parenthesis, e to the power, okay, but then 0.12 times 5 parenthesis, and you really need these parentheses exactly right here, because that will force the calculator to multiply those two numbers together before it raises to the power. Okay, and again, we get a decimal answer here. If I type this whole thing in, we get something just a little bit bigger. It turns out about 36,000. Let's see here if I still have it. $442 and about 38 cents. Okay, which, you know, if you're investing, by the way, the more often you compound interest, the more money you earn. So compounding continuously, which kind of means compounding infinitely often, is the best thing for the investor. If I'd compounded not 4 times a year, but say 12 times a year, compounded monthly, I'd be somewhere in between these two numbers. Okay.